I am going to provide for you some help on the homework. This is going to be collected tomorrow. So what we ought to be doing is looking at the model and writing an equation. I have 1, 2, 3y on the left plus 1, 2, 3, 4 units is equal to negative y on the right minus 1, 2, 3, 4, 5, 6 units. And then I'm going to solve the same way we've been doing in class. Start with the smaller of the two variable terms, and let's add the opposite to both sides. If I've got a negative y, then I'm going to add on a positive y to cancel it out. 3y plus 4y, or 3y plus 1y is 4y. The plus 4 is still there in my model. It comes straight down. I have negative 6 left over here. The equal sign always comes straight down. Negative 6. Now, let's take what is probably not the best step right here so we can learn. I could add 6 to both sides if I wanted to. Cancel out negative 6 and positive 6. That makes a zero pair, so you've got to hold the place value. You've got to show that there's nothing left on the right side. The equal sign always comes straight down. 4 plus 6 is 10, and we have 4y over here also. But I want all of my variable terms on one side and all of my constant terms on the other. So I'm going to cancel out a positive 10 with a negative 10. More zero pairs. That leaves a 4y on the left. The equal sign still comes straight down. 0 minus 10 is negative 10. And then now this is the division step. Every time it looks like this. Something times a variable equals a number. You're going to divide by that something. And this is a fraction you ought to be able to reduce down to negative 5 halves. Now, let's do it a slightly more intelligent way. When we're at 4y plus 4 equals negative 6, instead of adding 6 to both sides, we want our y's to be all by themselves. So let's take 4 from both sides. Zero pair. 4y is left over on the left side. If I have negative 6 and I take 4 more away, I'm going to end up with negative 10. Another way to think about it is I stole $6 from you, and then I stole 4 more. So now I've stolen a total of $10 from you. You're out $10 altogether. But you see how this is the same now, and we're here at the division step, and we're going to get the same answer. Y equals negative 10 over 4th, which reduces to negative 5 halves. So there's number 1. Now, I strongly suggested in class that you use a piece of paper, a separate piece of paper. This is why. See how this scratch page took half a page? I could have done it in a little bit less. There is no easy way to fit all that work on here in the margin or to just scratch stuff off of the models here. So it's really important that you do this on a separate piece of paper. If I don't see any work when I collect the homework tomorrow, then you're not going to get full credit. 1, 2, 3, 4x minus 1, 2, 3, 4, 5 is equal to 3x minus 1. And we want to know which of the 4 models does not represent a solution of x equals 4. So let's start with the smaller of the two x terms. Subtract 3x from both sides to cancel out the positive 3x. 4x minus 3x is a single x. The minus 5 is still there. The equal sign always comes straight down. The negative 1 is still there. And now we got the x term. to be all by itself, which means I want to cancel out the negative 5. So I'm going to add 5 to both sides. 0 pair. The x is still left over here, so we have x equals negative 1 plus 5. So I stole $1 from you, but then I decided to give you $5. So the first dollar brings you back up to 0, and the next $4 take you to your answer, x equals 4. So you can rule out f, but I want you to go solve the next 3 to figure out which one of those does not have a solution of x equals 4. And again, here I didn't do any extra steps. I took the most direct approach, and it still took about 10 lines for me to make it nice and clear. There's no way you're going to fit all this work over here in the margin or right down here, so I really do want you turning in a separate sheet of paper that shows me all the work you did. For number 3, I'm going to help you set it up just a little bit. We want one expression for Sally and one for Joe. Or maybe it's for Chris. Let's see. So for Sally, she's 1 year older than 3 times the age of Joe. So J is going to be my variable here. Sally is 1 year older than 3 times Joe's age. Chris is 5 years younger than 6 times the age of Joe. So 5 years younger, negative 5, than 6 times Joe's age. Or maybe instead of writing it in that order, you write 3j plus 1, and here you write 6j minus 5. It's equivalent. The skill here is being able to write these expressions to go with each of these people. We need some way to represent Sally and another way to represent Chris. And now we want to know if Sally and Chris are the same age, how old is Joe? So let's set Sally equal to Chris and solve for Joe. Sally is 3j plus 1. Chris is 6j minus 5. And when you do your solving steps, when you cancel your terms, you're going to end up with J equals or Joe equals. You may skip number 5. So that just gives you 4 problems tonight to do for homework. And I'm not going to insist you do the back, but let's not cross it out, because maybe that's something we do in class together.